Evening. So let's continue on. So last time we finished talking about fractals, right? Which are a fun way of doing graphics. Let's see if we can do something a bit more serious and more useful. We're going to try to plot a data file. All right. So first of all, let's see what a data file is. I haven't given you the link, unfortunately. So let me see if I can find it. So we're going to pick some public data. Right, there are many sources. All right, so here we're going to search for sunshine. All right, so there are many sources of public data available, one being the Singapore government. Right, and because it's local, and that makes it a little bit more interesting. So we're going to pick something that's very non-controversial, doesn't raise any political issues or anything. The amount of sunshine that we get in Singapore every year. All right. So there's a file here. So you see that there's a link, right? And there's a file here, and this represents a format. CSV stands for comma separated values. It's a very simple format. Probably those of you who have looked at R, learned a little bit of R, already know what that format is. Now, this file, I'm not going to download again. I have brought it here. Okay, so it's values separated by commas, one record per line. It starts with a header, which says pretty much what the data represents, what each column of the data represents. So the first column is going to be the month, and the second column is going to be the mean of sunshine hours for that month. All right, and then it starts from 1982. So this represents 1982 January, right? And for that month, there was an average of 5.6 hours of sunshine per day. Okay, and it keeps going, right? See, the format is very consistent, right? It keeps going until 2017 July. So since now we are in September, at the point when I looked at this data, I think it was still August. So there might be data for August as well. And in July this year, there were 7 hours, on average 7 hours of sunshine per day. Okay, is this clear how this is interpreted, right? So from our perspective, we want to read this file and put it in a data set, right? Which is going to be a list of tuples for us, right? So each line is a tuple, and then the records, one per line, are going to become the elements of the list. Is that clear? We're going to skip the first line, which is the header, right? Which is useful if we open the file as humans, but for the computer it doesn't say anything. It's not useful data there. Okay? So we want to understand how to read this data into Python and how to plot it. This is what we're going to learn next. Okay? So Python already has a package that reads this format called CSV. So we import CSV. All right. The first thing we're going to do is put the data into Python. And then we have to read the file. And this is the command that reads a file. the first argument has to be a string representing the name of the file. We want that to be an argument. And then once we have, what this returns is a file handle, right, which is a object representing the file on disk, right? So it's internal internal representation of a file for Python, all right? Once we have that, and what's really a file? It's a sequence of bytes, all right? And bytes are sort of integers, just that they're unsigned, and the range is, anybody knows? How many bits in a byte? How many bits in a byte? Really? Go to Wikipedia and search. So you never wondered when somebody says, well, it has 32 gigabytes of memory, right? It's gigabytes, and what that byte represents. 8, right? Why do we still work with 8 bits when our processors have 64 bits in a register? For historical reasons, right? The world of measurements has not evolved as fast as processors themselves, right? So we still measure information. So the unit of information is a bit, which encodes 2 possible values, right? And then the next one is 8 bits. With 8 bits, how many distinct values can we encode? What's the formula? To the power of 8, right? So with n bits, we can encode to the power of n. So the range of bytes is very small, from 0 to 255, right? To the power of 8 is 256, which gives us values from 0 to 255, right? So these are very small integers. These integers have various meanings. One of the possible meanings is characters, all right? So the text that you have seen here, in this text, each single character is encoded as 1 or 2 bytes, right? The file that you see here is the sequence of all those bytes. This guy is the sequence of all those bytes, right? And you would wonder, why is not a list? It's not a list because we don't want to read the file at one time in memory, all right? So we want to have something that we call an iterator, and we're going to learn what that is soon, right? An iterator is a lazy sequence, so it doesn't have to exist entirely in memory at any one point, right? We can build fragments of it in memory, and this way, at any one time, we consume less memory. But that's less important here, right? This object can be processed by this function, all right, by this API. API stands for Application Interface. It's what coders refer to when they have a collection of procedures that can work on something, right? So this CSV is an API, Application Interface, and the reader is one of those procedures in the API. It can take this file and it can give me back an iterator of strings. Actually, not of strings. An iterator of, I think, an iterator of iterators. All right? So an iterator is sort of like a list, just that it's not entirely expanded in memory at any one point. So what do we want to do with this iterator? Right? We would like to put it in a list. But we have an extra problem, right? We have an extra problem. And at this point, we should start doing the operations one by one, right? The month is specified as year dash month number, right? That dash is annoying to us because we would like to have the year and then the month separately. We would much have preferred to have a comma here, but these guys didn't give it to us, right? So then it would have been a much more simple CSV to work with, because we don't know how to process that dash. Okay, so we're going to do that, right, by separate means. So I'm going to do the following. I'm going to take these things and actually type them into Python. Let's do that. Don't. No, .csv. All right, so let me see if I have the file here. No, let's copy it. All right, Python 3, and we're going to do f import CSV. F is open, and we're going to say the file name, so it's I forget how I can read from dailysunshine.csv. All right, and we want to open it in a reading. So this R stands for reading. We could have used the write W, right? We could have had reading and writing, which is R plus. You can look at the documentation for open. You can do help open and find out, right? So it's open now. And now we can say CSV dot, and iterator is CSV dot reader or read? Can't remember, reader, and apply the file F. All right, and I'm going to make this into a list already. So I'm going to say L is list of it, and let's see what we get here. So if I look at L, right, L is a list of lists, right? Is a list of lists. So I can go to the beginning, though that doesn't make much difference, right? And each element, so this is one element, right? This is the second element, and so on, right? Each element is a list. What's inside the list? The columns, right? And you see the column, including the column representing the header. So the problem is that I would like these to be separate, and I would like the list to actually be a tuple, possibly, right? So how do we do that? So we're going to employ a map, right? Maybe we shouldn't do a map. Now thinking of it, there's because we did comprehensions last time, right? So well, we can say what I would like here is so first of all, let's take one of these strings, 198.7-01, right? So how can we split this into two parts? So there's a split, very good. And I can say I want to split it on minus. And what's the result going to be? A list of separated strings. Okay? Yes. Okay? So what we want now is a list of So we're going to have a list of tuples, right? And I'm going to say A and B0, B1 for AB in L. So for AB in L, the first one is so AB, and then one way I could do it very quickly is split on dash and take 0, and A dot split dash and take element 1, right? For AB in L. So this should give us a sequence of triples, right? So let's call it T. List index out of range. And the problem is that we cannot split the first. We cannot split this guy, right? So that's one problem we have. So we have to get rid of the first guy, and that's very simple. We can say here 1 onwards, right? And now this works. And if I evaluate T, what you see is triples, right? Where we have separated the year, the month, and the number of average number of hours per month, right? So let's see what's happening here. This L, we know what it is. It's this list, right? And I index it from 1, so I get rid of the header, which is not useful data for us, right? Now, when I say this, for every element in L, right, A is going to become this part, and B is going to become this part, all right? Again, please. Where is the lambda? What do you mean by lambda? All right. So then, this A is a string like this. So A dot split is going to be a list where the first element is this, the year, and the second element is the month, right? So then if I'm going to index that by 0, I'm going to get the year. And if I'm going to index that by 1, I'm going to get the month, right? Does it make sense? Okay. Now, there's another thing that I need. This guy is a string, right? As this one, and so on. We don't want these to be strings. We like them to be numbers because we want to plot them. So we want the numeric value. So how do we sort that out? What I need to say here? I need to do something to B. What do I need to do to B? Louder. Yes. Very good. Okay. So now, when we evaluate T, right, we see that this guy is a number. It's no longer a string. Cool? So we have performed our first data processing. All right. So what I'm going to do is I'm going to take this and actually copy it here. I have a much nicer way of doing things. right? And this should be list of it. Okay? So we're doing exactly this thing, right? We're producing the iterator. Actually, when we have an iterator, we're going to learn soon that we can iterate, move on through the elements of the list by using this function called next. So by just applying the next, we're essentially skipping the header. Let's not make it too confusing. Better actually leave this out, all in due time. Okay? So what we have at this point is our data. Okay? Now, we would like to plot this data. Okay? We're going to use two APIs, these two, Matplotlib and Pylab. Okay? And as we import these two things, P is already a plot. And we have to add data to it. So P is already like a canvas on which we add our graph and we add our annotations to make our graph nice. And the amount of things that you can do to annotate, beautify it, put multiple graphs on it is, there's a lot of flexibility. All right, so we're going to do just a very simple thing. So let's import this. Let me see if I can put these two side by side. All right, so I'm going to change the name. Otherwise, I would have to use Pylab, and Pylab is too long, right? So there's already a canvas prepared for us. So what do we call it? T. Let's first perform the plot, so we understand what it is about. And then so I'm going to add the ticks. Again, there's an LST, which for us is T now. All right, we get some stuff that we're not really interested in knowing what it is. And then the magic happens when we say p.show, right? So all the drawings have already been placed on the canvas, and now we show the graph. And obviously it's good to have a big screen, but let's try to magnify this and see how far we can get. Okay, so this is the graph. I'm not sure whether I can, I can magnify it even further. Okay, so I can zoom a rectangle. So let's say I will take this area. All right. So what you notice is that we have a graph made up of black dots that are joined with lines, all right? And we have these labels here. And obviously the y-axis will be the number of hours, the number of average hours per day. Okay, and this is the data. It happens automatically, right? The data that we're plotting is not so important, right? We're just picking something. I was actually hoping that I would notice, some sign of global warming, but as you can see, not much, right? It's pretty much there are interesting cycles, right? So you have to think there's not enough room to put the months in between, right? So you have to think of the fact that there are 12 months in between. Yes. Oh, okay. All right. So there's clearly a pattern. There's more probably in the summer, in the months of June, July, and then there's less in December. So it's pretty natural. But the data that we're plotting is not important. The important thing is that there's a function that does everything for you, right? So we've done two things. We've added the data in a very clear format, a list of triples, all right? And then we've added the ticks, right? Remember, we ran two operations, and then we asked the plot to be shown on the screen. And then the plot, as it shows up, it comes with a lot of goodies, right? So you can, I think, make it a little bit larger, right? I'm not quite sure all these things what they mean, right? You can move through different different regions and so on. Okay, is this clear? So let's look at the code and see again what we've done. Okay, is that fine? Right? So two things. One is you have to understand that capability exists, right? And two, it's so powerful that you don't have to do the drawing yourself, right? You only have to provide the data. That's about it. Okay, so let's look at the data. Right? So after we import this PyLab, right? PyLab itself is a canvas, but we have renamed it to P so that it's faster. Okay? So what do we plot? We are using two lists. And this lambda at this point, we did the float here, so this float is no longer necessary. I'm just going to remove the float. All right. So we need to extract what represents the data, right? We need to provide data for the x-axis and the y-axis. Okay. Now, for the x-axis, we have some sort of heterogeneous data, right? We have years and months, right? Which start in a very arbitrary place. So it is easier for us to provide a, all right, and also we don't want to provide too many, no, we want to provide one data point for every month, right? So how many of them are going to be? Well, they're going to be the length of the list. So the list called T that we used in the interactive environment, now it's called LST because we're writing a procedure. All right. And what we're doing is we're creating a list of numbers from 1 to whatever number of data points we have. Okay? We do not, so there's two things, right? The x-axis contains heterogeneous data, and also the data is too long to be displayed fully. right? I can't for each data point put the year and the month. It's going to be too cramped, right? And then I want to put ticks for on the x-axis. But before we get there, right? So for the y-axis, for each point in here, for the y-axis, I want to extract what? The third component of the triple. Right, so I have a list of triples. The third component of the triple represents the float, right? It has the number of hours that we want to plot. So x2 is going to be exactly that quantity. So I create a list of just integers, because that's convenient. And I create a list of numbers that represent the value that I put on the y-axis. And then how do we want to print? Well, we want to use the color black. So the letter K stands for the color black. And how do I know that? Well, you need to do help plot, and you'll find out the colors, right? Or you can Google PyLab, and you're going to find the codes for the colors. The O represents the dots. So I want black color, I want dots, and I want the dots to be joined by a minus, right? All these strings are documented on the help page, right? You can use diamonds, you can use anything you like, X's, and so on. Okay, so now for the ticks, what do we want to put on the do we still have it? Yes. Right on the x-axis, right here, we want to put something, right? Ideally, right? And in this case, we want to put the years. We don't want to put the years and the months, right? So I want to put a year every 12 data points, right? So in order to do that, I'm going to create a list, right? That represents the data points where I want to put a tick, right? So this has to be a subset of this, right? This has to be a subset of this. Understood? And it is obviously because I'm using the same range, but with a pace, with a step of 12. So I'm going to go from 1, then 13, then 25, then 37, and so on, right? So I'm going to go every 12. So definitely what I have here is a subset. And then I want, at each of these points that I indicate here, I want to put a number from here. And now we know that the first year is 1982, sorry, right? And how many of them do we want? Well, 1982 plus the length of the list divided by 12 plus possibly 1, right? So you're going to think that, oh, well, this might produce a longer list than needed. No worries, the shortest of the two is going to be used, right? So the shortest between this guy and this guy. Meaning that if I'm going to put a tick at a point that doesn't appear in this range, then that tick is going to be ignored automatically. Okay? So this is the two things that we're doing here, right? If you take a good look at the documentation there, you can do a lot more stuff. Okay, but I don't want to burden you with things that don't represent concepts of programming, but rather just knowledge that you can grab from the documentation directly. Okay. Now I'm going to want to do this better. So instead of doing the map, I'm going to do x2 . Okay? That's a lot easier. Plot wants lists. So if you provide ranges, it's not going to work. Yeah. So you need a list here and here. Again, please? I can't. If you don't. Oh, pip install. All right. Um, pip 3. Right. So you're going to see requirement already satisfied for me, and pip install pylab, which actually might not be necessary. Yeah, so this one is not necessary. It's included in matplotlib. Okay, so let's run these two. Together. All right, so I'm going to take these two functions. Notice at the same time that I am not importing at the global level. Right, I'm doing the imports as localized as possible. Right, so this is also good practice. I could go and do import CSV here. It's not an error, and if you do it in your assignment, you're definitely going to be penalized for it. But it's good practice. It's good to remember these things. All right. So now we have two functions, right? So we can say get data from the file sunshine. What was it? Daily sunshine. Yes. And then let's put this into an iterator, and then so actually this is not an iterator. This is a full-fledged list. We should have said that it's a list, but now we call it an iterator. And then we can say plot data iterator. Right, and this gives us the plot. Right? So now one thing you can do is go to the site, right? And this actually is going to be a part of your homework. Get another CSV file, right? That might actually have a different number of columns, and plot that one. Okay. Any questions for this part? Actually, let's go back to the code. It needs to be in CSV format. So yeah, but so we took advantage of, we put it in the same folder, right? So if I exit Python, you're going to see the file right here, right? So it's in the current folder. If it's not in the current folder, you have to provide a full path. All right, so be careful of that. And if you're doing that in Windows, backslash is double backslash. You know that? right? So if I say this, there's going to be syntax error, right? So to get a backslash inside a string, I have to double it, right? Because backslash is used as the escape character for a lot of control characters. For instance, if I say backslash n, right, let's say a backslash n b, backslash n is the carriage return character that sends the output to the next line, right? And you're going to see this only when I use print. Right, so print, right, you're going to see a and b. So this character, which is a control character, tells the printer to go to the next line, right? This backslash is the way to create these control characters, right? So every time the Python sees a backslash inside a string, says, oh, the next character is some sort of a control character. If I want a backslash, then I have to put backslash backslash. If I want a real backslash in there. Does that make sense? So when you're in Windows, you're going to say something like this: C, I don't know, users, right? Your name, documents, I don't know, daily. Right, so this would be a valid string in Python. That yes, yeah. So if you want to have an easy life, just put it in the same folder. And, okay. That's because I code in I do functional programming on an everyday basis, and I'm very biased towards using map and fold and other functions, whereas the Python way of doing things is a bit different, right? Um, so this is more natural in Python and probably easier to understand for you. So I think it's a better solution. The final column. Here, right? So what we're producing is what LST is it's a list of lists, right? So when I take the X as an element of LST, X is a list. LST is a list of lists, therefore X is a list. Is that clear? But X will have 3 elements. So every element in LST being a list, it's actually a list of exactly 3 elements, right? Or a tuple. I can't remember exactly what I made it. Or a tuple, right? So therefore, this X having 3 components, I want to get the last component. Okay? So one thing you can do is experiment with, for instance, I can hide this. So we read the data, and as we plot the data, right? Notice that we have labels that are the default ones, and remember what we have used as x-axis are numbers from 1 to the length of the list. So the plot library will just give us numbers, ticks every 100 elements, right? We're getting the default stuff. Okay? Now, if I add this, but I hide this, then it's not going to work, because this has to be a subset of this. So the plot has no way of verifying this subset relationship unless I execute this line. Okay? One other thing we can try is use a different color. Let's say red. Okay, let's just do it faster. Okay. So now I have red lines. Okay. I think if I use a D here, I might get diamonds. Yeah. I'm not sure whether the recording is still going to work. Hopefully it will. Okay, so you see little diamonds. Okay, does it make sense? That's stuck. Oh. Oh, it's capitalized. 7492. Okay. Can I move on? All right, so let's do a more sophisticated data processing example. So let's say that we want to find the amount of sunshine per month, the average amount of sunshine per month across the years. All right? Does it make sense? So I'm going to take the month of January across all the years. So I'm average all the values. The month of February across all the years. So I'm going to average all the values. Right? Cool? All right. So let's see how we're going to do that. And again, I'm very biased towards map, but map doesn't mean anything but this. Okay. So we're going to reshuffle. We're going to reshuffle the elements. Okay. So remember, the first one was the year. The second one was the month. They were both strings, and they are still strings, and that doesn't bother us. All right. And then the third one was the average number of hours. So we want to put the month first. Okay? We're going to do a little trick. So we're going through the entire list and we're reversing the order, month and then year. And then remember that triples can be compared, right? And then, because the sorting operation, what does sorting mean? Everybody knows? Sorting is putting them in order, right? Sorting requires comparison. But I can compare triples, so I can sort a list of triples, right? How is sorting on triples? How does comparison on triples work? Lexicographically, right? So I compare the first component of each of the triples, right? If I can decide which is first, then I can stop right there. But if I can't, if they are the same, I have to move to the second component of both triples. I compare those. If I still can't decide, I'm going to move to the third, right? So as soon as I can decide, I stop. So that works. And because they're ordered by month, this sorted is going to produce what? Month 1 of 1987, month 1 of 1988, month 1 of 19 up to the first month of 2017, right? So this sorted, let's write here, is going to produce, right? So a list where I have 0, 1, 1, 9, 8, 7, and some hours, and then 0, 1, 1988, and some hours, right? And I'm going to go with this up to 12, 0, 1, 2017, and some hours, right? So you see, I have all the month of January at the beginning of the list, right? Then it's going to come February, 1987, and some hours, right? And I'm going to have the entire month of February. So 02/1987 to 02/2017. Is that clear? And it's going to move on to month of December, right? 12 months from 1987 to 2017. Is that clear? All right, so we have this grouping. So now, one nice thing that I would like to do is to turn this into list of lists. That would help us a lot, right? Yes? So then I have a sublist that represents the month of January and an entirely separate sublist that represents the month of February, right? And guess what? There's a function that does that for free. Library function. It is called group by. What MATLAB? What do you mean MATLAB, right? So we're importing it from IterTools here, right? But there's no problem importing it. So this does the following, right? It takes a list, and we also have to provide a threshold function. When the function changes value, we move on to a new sublist, right? Our threshold value is the first component of the triple, which is now the month, right? So we're going to take the first month of January, and when we reach to the first element that has the month of February, this function changes value, right? So then group by says, oh, it's time for a new sublist. And we'll create a sublist with all the elements with the month of February. And when it gets to the month of March, right, this T0 becomes 3. So as it changes from 2 to 3, group by will say, oh, it's time for another sublist. So the result here is going to be 12 sublists. So I'm going to have a list of 12 sublists. This is a very neat trick. One that hopefully you'll spend some time understanding and you're going to be able to replicate it. So it's essential for data analysis. In most data analysis, you're going to need to do a group by. Okay? So what did we do? We did sorting of some sort in such a way, right, that values that need to be together, they appear consecutively in the sorted list, right? And then I do a group by with a threshold function in such a way that every time I change the group, right, that threshold function changes its value, and therefore group by knows how to put them in separate sublists. Okay? So now, that's again change this into from in. All right. And also here, that's lambda t. So this is for t. Is correct. So group by month. All right. So at this point, I need to show you step by step because um, let's do up to here step by step. There's a peculiarity of group by month that you need to experience directly. All right. So let's do. Let's actually keep this. All right. So I want to import group by. All right. Then with month first. Let's get data, right? So what do we call it here? LST, right? So LST is this guy. Okay. Oh, I didn't want the plot. I only wanted the data. All right. And then we can do this guy. Right, so this reverts the month and the year. and this will do the sorting. All right, so let's see them with month first. Right, so notice that here now we have the month first, right? Month, year, everywhere we have reverted, right? Month is the first. And then when we sorted, right, they're all sorted by month now. Well, there's a lot, right? So you see 0, 1, it starts here. And then it goes up to here, right? This is the month of January. And then we start the month of February, and it keeps going up to here, right? And then the month of March. So what we would like is that, right, each of these individually highlighted regions to be put in a sublist. So this is what group by does. But group by does something that we might not want so much. So let's see, which might be useful in other situations. So well, let's turn it into a list. And actually, you'll have to believe me now that this is the sublist where we have the month of January, right? It's an iterate. But also see how group by works, right? It doesn't just give me the iterator with the sublist, with the sub-elements, right? It also gives me the month as a separate record. All right? So to give you a better impression of what this is, let me so list of map lambda x y x list of y. Group by. Oh, come on, what's this? Oh, because this guy is all right. X 0 list of x1 again. So group by month is a list of pairs. So x is a pair. So I'm putting it back. Oh, all right. I know what the problem is. Okay. So this is essentially what we're getting, right? You see, I'm getting the list this is I'm getting the list which goes up to here, right? Is it clear? So this is the list that I want, but it is inside a pair where I also have the 0, 1, right? So the 0, 1 appears in every element, but group by does something that we don't want so much. It also adds a pair and puts the 0, 1 in here. This 0, 1 represents the value of the threshold function, so the one that came from here. So whatever I put here, it will make a sublist and pair that sublist with the value of the threshold function. Okay? which in this case is redundant. Okay? So we want to get rid of that. You don't understand? So group by does something that we don't want. Does something useful, but something that also isn't useful. Right? What we would want, looking at this, right? This is a very useful result because I have all the 0, 1s grouped together, right? Up to here. So they're grouped together. The 0, 2s are grouped together. So I would like these 0, 1s to be put in a sublist. I would like the 0, 2s to be in a separate sublist, the 0, 3s to be in a separate sublist. Is that clear? Right? So group by does help us to a certain extent. It creates this sublist. You see it here. It creates it, right? But what we would have liked is this sublist, and then the next sublist, and then the next sublist, and then the next sublist. But instead of doing that, right? Look at the highlighted part as a single element, right? And then how is this single element embedded? Well, there's this 0, 1 here, and then there's this entire pair here that is really bothering us, right? So the list is inside a pair, but it's inside a pair. It's not available directly. So I have to get it out from there. Okay? Yes. So the round bracket here starts the pair. And there's a round bracket here that closes the pair. The pair has 2 elements. 0, 1 is the first element of the pair. There's a comma here. And the entire list that starts here and ends here is the second element of the pair, right? So what I want to do is, and this pattern repeats. There's another pair starting here. Right? The round bracket is the first element, it starts the pair. The closed round bracket closes the pair, right? And then 0, 2 is the first element of the pair. And then you see a square bracket here. That starts the second element of the pair, which is a list. And this is the list that we want. It has all the 0, 2s. Yes? So I want all the 0, 1s. I want all the 0, 2s. I want all the 0, 3s. The 0, 1 that you see here and the 0, 2 that you see here is the value of the threshold function. You see? We're using this threshold function that changes value. Whenever it changes value, it's a new sublist. But when it creates that sublist, it puts it in a pair with the value of the threshold function that was gotten from here. Okay? So that sometimes is very useful because you don't always get a threshold function that represents a component of your data. Sometimes it can be a complicated computation and you don't want to lose that value, right? But in this case, it's redundant because the number that I have here, it's also the number that appears in so many places inside the list. So now what we want to do is extract this, okay? And then move on and extract this and put all that in a list, okay? So we're going to do that. Right? We're going to do that here. So with only sunshine, is exactly that. All right? So now if we look at with only sunshine, It's actually even more simplified. So there's one thing why this empty list keeps happening is that an iterator can only be consumed once. Once we have consumed it, it becomes empty, right? So in producing this list that you see here, we consumed it already, and then it's empty. So let's do it with our empty sunshine again, and then get this. So actually, we simplified it even more. Instead of extracting the list, we have extracted only the sunshine, right? So I kind of lied when I told you that we want the sublist, right? What we want is actually to keep this guy, but from this list that you see here, from this list, instead of keeping the triples, all right, keeping only the hours, this guy and this guy and this guy and so on, right? So now you see that, for instance, for 12, right, you can see that the last element here is 5.1, so you can see it here, right? And the one before is 5.3, and you can see it here. Okay, so that's what we do, right? We keep the month name, and then we get all the average sunshines for the month of, say, December. Is that clear? So how do we do that? Well, this P is an element in group by month, right? And I'm going to do it for the month of December, right? Because it's close here. So this is one element. This is one P. All right. So this P that you can see here, this P is what I have highlighted. One possible value is what I have highlighted, right? So you see that the 12 here is the first component, meaning that is this P0, right? Is that clear? So this 12 that you see right here is P0. So I'm going to put it back where it belongs. I'm going to create a list of pairs, and P0 is in the same place where it was. Is that clear? So now let's see what we do with the list. The second element, P1, this P1 that you see here, is a list. It's the list that starts here and ends at the square bracket here. The highlighted one, the one inside a highlight. Okay? So that's P1. And that's a list. So because it's a list, I can use it in the list comprehension. Okay? So I am going to extract T2. The float is redundant here. So I'm going to extract T2 for all the elements in this list. For all the elements in this list, the T is a triple. Right? So P1 is this list. P1 is just this list. And when I say for T in P1, T is going to be a triple. And we're going to become every triple. So T2 is going to be this guy. This T2 is going to be this guy. Oops. This guy. And maybe later this guy, right? So this is the average number of hours. Does it make sense? Just removes, essentially we no longer need this part. Right? I don't need this, I don't need this, I don't need this, right? What I need is this guy, then this guy, then this guy, right? The third component of every triple. The third component of every triple is T2, right? So ignore this float. So that's one thing that we should be doing now. This float is no longer necessary, so things become even simpler. Okay? So now, we're very close to the result. All I need is, right, this month and the average of this entire list. And then this month and the average of this entire list. Is that cool? Understood? Yeah. So, the easiest way to do that is to have an average function, which is very simple. It returns the sum of all the elements divided by the length of the list. Okay? So then the average sunshine is going to be average of P1 and P0 okay. Now notice again that we have reversed them. So I'm going to put the hours first and the month second. What we want to find out, okay, so let's do this as well. And you're going to understand immediately why I'm doing that. We don't have an average, right? So let's define the average. Okay. So now, for January, I have 5.65 hours across all those years, right? For February, I have 6.98, right? For March, we have 6.18, and so on and so forth, right? And I would like to find out the month with the most sunshine, right? So if I do max of this, because max requires comparison and we can compare pairs, right? I can do AVG sunshine, right? And we find out that the month of February is the one with most sunshine. A bit strange, right? But it seems correct because if you look at all the others. So now, why did we switch, right? Previously we had month and hours. Now we have hours and months. Why did we do that? Why did we switch? Why did we reverse? Exactly, right? So if we hadn't reversed them, the max would have returned December, right? So it's another neat trick, reordering elements of a tuple so that comparison works in your favor, right? So then sort and max can become very useful tools. Okay? Is this more or less clear? Okay? So this is what data scientists refer to as data munging. What we have done is data munging, right? As you can see, it's relatively concise. It's something that an experienced coder would write in maybe 10 minutes. Okay? And it would reach to writing it in 10 minutes in about 10 years of practice. Okay? So it's the 10,000 hours. Remember you know the 10,000 hours, right? Okay, cool. So yeah. So obviously, I mean, you're going to get some of this stuff in your homework. Nothing so convoluted, right? But I would like you. I want you to have an example of what people do with Python in real life, and this is a very typical example, right? So they wrote this little function. It is exactly that they would use it in the interactive environment, right? And we'll play with the data and graph it, and then they would try to maybe do a little bit more, right? Try to infer a correlation between two data sets, do a little bit of regression, right? Keep looking at graphs and adjusting parameters, and looking at graphs again until they decide, oh, this is the set of parameters that gives me the best correlation, the most probable correlation, and that's what they publish. Okay, so yeah. Okay, questions? No? Cool. So you might have noticed that the grades are out. Unfortunately, I made a mistake in your second homework where I still graded on a scale of 1 to 10 when I should have done it on a scale of 1 to 15. So take those grades and multiply them by 1.5. When I get home, I'm going to correct. The weightages for the homeworks, we have 5 homeworks, are going to be 10, 15, 20, 25, and 30%, right? I think it adds up to 100. There's a contest that gives you another 10 marks. So in total, you can earn up to 110. Obviously, the excess is going to be forfeited, but gives you a better chance of reaching the 75, 80, 85 range, which will give you the A+, A, and A- grades. All right. So I'm going to try to grade on the standard scale, right? So above 80, you're going to have an A, and then it goes down by 5 points, just to keep in mind, right? So you would have, for the contest, which is the 10%, just submitting would earn you those 10%. Submitting a piece of code that runs, doesn't bomb, okay? So I've had a few examples of code that bombs. So yeah, so code that bombs generally doesn't earn much. It has to at least produce some output. Cool? Yes, please. Oh, you don't know that? Oh, seriously. Uh, so if you go to IVLE, you're already enrolled in the course, and it should appear in your homepage. Okay? I might. Okay, so let me check. So now that you mentioned that, I think I need to publish, explicitly publish, say publish. Okay, so sorry about that. So they're graded. So then later tonight you're going to find it out. I'm also going to correct the marks in that case. Good, because I was expecting everybody to come here and say, why did I earn so few marks in the second assignment, right? It's because I forgot it was 15 marks instead of 10, and I marked on a 10 marks page. Okay, so all right, so I'll do that then, and be prepared to read your marks. I'm going to try to keep grading on schedule every week. Don't forget a contest. All right, I'm going to have the regular deadline for the contest. So I can't allow you more than next Monday, because then I have to allow you a week to vote. All right. So by the last class, which is 1 week from Thursday, I need to know the winners. Okay. Cool. Thanks. See you next time then.